Okay, let's give this a try. We are going to be starting with 12.2 chemical calculations. Just to remind you of where we came from here a little bit, we were using in chapter 10 this document. I think it's called Mole Roadmap. Hopefully you can find this. If you can't, it is posted to the classroom again. Remember, we used this mole roadmap to convert from one thing to moles. So we went from mass of something to moles of something, volume of something to moles of something, particles of something to moles of something. And that's helpful, we talked about, because in chemistry there are so many particles, they're so numerous, you just simply can't count all of the different molecules of something. So switching it to moles helps to reduce that. We compared it to like a dozen apples. Instead of counting out each apple, you just say there's a dozen and you know how many there is. Same thing with the mole. It helps us have an amount that's tangible. And we said that that amount of 1 mole is equal to this 6.02 times 10 to the 23rd particles. So this is where we left off in chapter 10, doing some of these conversions, using molar mass, simply going from the mass of one thing in a chemical to the moles of that chemical. Well, now we're upping the game. Stoichiometry, the point here is to be converting from a known amount of one substance, which you can see on this picture they call substance A. So we know the amount of substance A, and we want to figure out how much of substance B we have or need for a reaction to occur. So if you think back to some of the labs that you were doing in chapter 11, where some of you changed like the amount of, I'm trying to think of manganese dioxide. Some of you are using that black powder that you added to get that popping sound. If you knew how much manganese dioxide you had, then you should have been able to calculate exactly the amount of, I'm trying to remember, was it CO2 gas or hydrogen gas? I can't remember the exact reaction that you were doing there. That amount of gas, you should have been able to calculate the exact amount that would have been produced based on how much you put in. A lot of you were just guessing if you increased one, you would increase the other. You could have calculated exactly the number of grams or the number of moles or however you wanted to put it into there. You could have known exactly how much product you were going to get out. Or if you were going to put in manganese dioxide, how much of whatever the other reactant that you used in that reaction would you need. So you can see where this becomes really helpful when you're doing those labs in chemistry, and you can actually predict the outcome based on your math. This stoichiometry island, as it's called here, you can see there's kind of our old document. There's two of it now. There's one on the left side where you go mass, volume, particles to moles. And then there's one over on the right side, mass, volume, particles to moles. So you should read this from left to right. Left to right. So in this case, maybe we have grams of a substance, and we want to convert that to moles of that same substance. And then once we know that, we want to use that to then convert it to moles of this other substance, of substance B. But let's say we don't want to leave that in moles. We want to be able to actually weigh it out on our scale and know how much we're talking about. So we're again going to convert that to grams, to a mass. So rather than just stopping on this left side and going from grams of substance A to moles of substance A, we are now going to take it another couple steps and convert it from substance A to substance B in moles, and then also taking that to mass or maybe volume or particles. Obviously, this shows all the different options of what we can do with this, okay? But first, what we're going to focus on is just this middle part. How in the world do we go from moles of one substance to moles of another substance? You see it says here, use coefficients from balanced chemical equation. That's what we're going to check out now, is how do we do this middle part? Because that is what's new. We know how to do this first part. That was chapter 10. But now, how do we go from there to a new substance?